Okay, so a system of equations is when we have two or more equations. Now, how do we solve this system of equations? Well, we have to find the common solution to find the solution to solve this equation, these systems. So let's get the equation here. Y equals negative x minus 2 and y equals x minus 4. And there's multiple ways to find the common solution between these two equations or this system, but I'm going to be looking at maybe the simplest one, which is graphing. So let me just get a coordinate plane right here. There we go. And let's start by graphing the first equation right here. So we have the y-intercept of -2, so let's go 2 down, right here, -2, and plot ourselves a point down here. And we have the slope of -1, so I'm gonna go 1 back. So here we have -1 and 1 up. Right here, let's plot a point. And then let's do the second equation right here. So I will just we have the y-intercept of -4. So I'll go down here, -4. Let's just put a point down here, and the slope of 1. So we can just go 1 up, here 1 up, so we have -3 and 1. So we plot the second point here. And then let's just do a line. So right here we have a line. And let me just extend it to the other side. And then here, let's just do the other line. So let me just get this line. And what you will see here is that we are crossing between these lines. And this is our solution, the part where both of these lines cross. So let me just fix the line a bit. There we go. So as you can see, the line crosses here. So we get 1 and -3. And let's just check these. So let's just check these with the equation so we see if it works for both of them. So let me just do y, or rather our y here is now -3 equals, so -1 minus 2. Is -3 equal to -3? So here, 3 equal to -3. Yes, we can see that -3 is equal to -3. So let's test it for the other equation here, which is, so -3 equals 1 minus 4. Is -3 equal to -3? Yes, so here we have solved this system here because we found the common solution. So we usually put the solution in an ordered pair. So the solution to this one is 1, -3, as you can see. All right, let's see. How about another equation? So how about we have here y equals 2x plus 1 and y equals 2x minus 2. So we're going to do this again by graphing. So let me just get a coordinate plane. There we go. And let's just start by graphing the first equation. So we have here a slope of 1. So here 1. Let's plot the point down. And the y-intercept of 1. And we have the slope of 2. So here we have to go 2 up. So here we have 3 and 1 to the right. And then let's plot the second point. And then here let's graph this one too. So we have 2x minus 2. So our y-intercept is -2. So here in -2, and let's put this point. And our slope is also 2. So we go 2 up. So we go to 0 and then 1. So our second point is here. And let's do a line. So line for these two. Here, let me just extend this line. Here we go. And then a line for the ones here. So let me just switch to the color green and add a line. Hold on, let me just, I know this is taking some time, but there we go. Oops. And I think that's all. There we go. Now, I'm not sure if this is the most accurate graph in the world, but as you can see, our lines don't seem to be getting any closer. And if you know a little bit about perpendicular and parallel equations, we see that both of these have the same slope. That means they are parallel. That means they will never meet. So, what is the solution for this system over here when the lines never meet? Well, the solution is there isn't one. We have this sign to represent that there is no solution. Or you can just write down here, no solution. No solution. Here. So when you see them have the same slope, the exact same slope, you know that they're parallel and the lines will never meet. That means there will be no solution, and you can present it with this sign here or by saying no solution. Okay, so for our final example here, we have x, or let me just draw this x correctly, x plus y equals 3, and 2y equals negative 2x plus 6. And let's just solve for y for both of these equations, so we have it in slope-intercept form. So let me just get this over here, and x plus y equals 3. We're solving this equation. We subtract x from both sides. This cancels out, and this becomes y equals negative x plus 3. And then for the other one here, let's solve for y. So 2y equals negative 2x plus 6. And let's divide 2 by both sides here. 2 and then 2. And this cancels out. And then it becomes y equals negative x plus 3. Now, if you've noticed something, these equations are the same. This is the same as this one right here. So if we were to graph it, so if we were to graph this thing right here, and like that, okay. If we were to graph it, it would end up just the lines would be on top of each other. So if you know, like the green line would be like this, and if there was a red line, it would be like this, and it would be on top of each other. So how would we, how do we, what is the solution for this system right here? Well, our solution is actually just this equation right here, because you know, if you want to like think about it, if we have anything on the line, it'll be the same for both these equations, because remember they are the same equation. So our solution would just be solution here. So let's write solution. Solution would be the equation. So y equals negative x plus 3. And this is the importance of having both of the equations in the same form, so we can see if they actually are, if this is just the solution or there's something else going on. And this is the final example. Thank you for watching. If you have any questions, just comment down below, and bye.